Good evening and welcome to the Professional VMware Brown Bag. This is the APAC edition and I'm Alistair Cook. This is the final of the VMware Certified Advanced Professional 5 Data Center Design Series. It's really just a grab bag of things that I found that I thought we hadn't quite covered enough or that bore a little more looking at. You can find the you can find the Brown Bag series at professionalvmware.com/vBrownBags, and you can find lots and lots of other locations just on the second slide. So we are running, as always, with the hashtag of vBrownBag, and I've even got a little tiny window somewhere on my screen where I can follow the end of Twitter with that. The downloads, good friend Nick Marshall is going to get all of the material back up onto the download feeds for us in the evening this evening, and they'll be available to you following that when he has some time away from his family. Currently the US Professional VMware Brown Bag is running through the VCAP5 Data Center Administration material, so you should be aware that that exam is currently in beta. And of course, first rule of Beta Club is you can't talk about Beta Club, and the blueprint is available to us as people have been invited to join the beta, so there should be some good material out of that. In the APAC region, I'm planning to do more of a what's new treatment on it. Having studied previously for the version 4 DCA exam, I really want to concentrate my study for DCA 5 on the things that have changed since version 4, and so that's what I'll be aiming to cover with this time zone. If you would like to take part in that, do drop me a line. I've got my Twitter handle there. My website, on the website is an about page, and that includes various ways to get in touch with me. So if there's some area of the data center administration materials, and it's particularly oriented towards command line operations for advanced functions, if there's some areas of that that you would like to contribute to the Professional VMware Brown Bags, very happy to have more people coming in and helping out and producing the material. I know there's going to be a lot more preparation required for me at least to prepare for the presenting the DCA material in the Brown Bags, and of course lots of study for the exam. So looking forward to doing some of that in the future. Professionalvmware.com for the rest of the material around the US-based Brown Bags, which of course for most of us here in the APAC region either happen before we start work or when they're in the middle of our working day, and unfortunately I never managed to be able to get to those. Today's material, lots and lots of little pieces. So one of the things that I don't think we've discussed in any great depth is the idea of a management cluster, and this is a construct that comes up in some of the architectural designs for a larger customer. So they're a customer that's got dozens of ESX servers. And in that situation, and particularly as they get to a more advanced, more cloud-like deployment, it becomes really important that the management of the group of ESX servers that delivers services to the business is not actually done on that group of ESX servers. And products like vShield are much easier to manage if you're not subject to vShield where you're doing the management. So the idea is that these larger customers are going to build a small cluster that's off to the side of their main environment. It's typically only a 2 or 3 ESX server cluster. And in this cluster, they'll run all of the management components for the vSphere environment. So this is where vCenter and its database go. This is where the plugins for vCenter, this is where the management components are placed. Generally, if we're using Active Directory for authentication, this is where we'll put a domain controller, and it is very important that that domain controller be a DNS server and a global catalog. One of the scenarios that we're protecting against is the total failure of all of the other ESX server environments, that this is going to be the sole surviving collection of ESX servers. And then we need authentication for a large number of our management functions. Another philosophy, another look on this is you'll know about vSphere Auto Deploy, which is the pixie boot your ESX server all of the time, and you'll know that currently one of the weaknesses of the solution is that it's a single point of failure. Your auto deploy server must be up in order for one of your auto deployed ESX servers to successfully reboot and return to service, as must vCenter. Well, you can't then run vCenter or auto-deploy on top of an ESX server that's dependent itself on auto-deploy. So this again plays into the having a management cluster of some group of ESX servers that have local boot media for their OS install and probably a small SAN somewhere in order to hold the collection of virtual machines and protect it with HA and DRS. But this is also where your auto-deploy server will sit in a nice, carefully managed, fairly tightly controlled, fairly slow changing environment on this management cluster. Gives us good scalability, gives us good manageability. It really protects the ability to manage the environment from the workload inside the environment. It's the sort of thing that's very much best practice for cloud scale deployment where you've got hundreds of ESX servers. It becomes very important that you protect the actual manageability. So I guess I should have also listed vCloud Director as something that would go inside this management cluster. I've not seen it in the customers that I deal with because most of the customers I deal with are relatively small. But I definitely see it as a very good idea for a customer that is larger and that has dozens of ESX servers in their environment. As always, do put up questions in the chat if there's some comments that you'd like to make on the material. If there's something that you think I've missed on it, hit it up in the chat. Second subject area I wanted to talk about was NUMA. NUMA is something that certainly as I'm teaching the VMware training courses, it's mentioned that NUMA is important, but we never actually discuss NUMA in any of the courses that I've noticed. So NUMA stands for Non-Uniform Memory Architecture or Non-Uniform Memory Access. And it really became important to us with Opteron CPUs, but more recently with the Intel CPUs, with the Nehalem and Westmere CPUs, these are inherently NUMA things. These are a NUMA architecture inherently where you've got multiple sockets. They've become NUMA because what's happened is that Intel have put the memory controller actually on the CPU die. Inside that CPU package is not just the actual CPUs but also the memory controller. And this allows them to very tightly couple the memory controller to the CPUs. But as a consequence, each CPU socket has some memory that's locally attached to it. You can see in the diagram in the bottom right that I think is stolen out of Frank and Duncan's clustering deep dive that I'm sure you already own. You can see there that we've got two CPU sockets 1 and 2, each of which has 4 cores, and each of which has some memory that is directly attached to that CPU socket. And then between the two sockets, we've got that yellow interconnect. If a core in CPU socket 1 wishes to access memory that's local to CPU socket 2, it has to request it over that interconnect and then from the remote memory management module, memory management on that die. So it's slower to access memory that's attached to a different NUMA node. The CPU's inside CPU socket 1, which is one NUMA node, the NUMA node is that CPU socket and its associated memory. So that group of cores, those 4 cores, are closely associated with one chunk of memory. It's fast to access memory from within that node, but it's slower to access across that interconnect to another node. Now the diagram only shows 2 CPU sockets, 2 NUMA nodes. We could have a scale-out environment. We could have 16 nodes, each of which is 4 cores, each of which has a chunk of memory. And that's absolutely as a supported environment. That's the kind of architecture that you have to get towards where vSphere tops out at 160 CPU cores per host. If each of the CPU sockets is running, even if it's running 8 cores, we're still talking about 20 sockets. That's definitely going to be a large NUMA environment. Now, the important thing about NUMA is that it means that our ESX server is not just one amorphous lump of CPU and memory. It's a series of modules of CPU and memory, and these are these NUMA nodes. For best performance, for highest performance and most predictable performance, a virtual machine should live entirely inside one NUMA node. So here we've got a quad-core node with a certain amount of memory. Maybe this ESX server's got 2 sockets and it's got 64 gigs of RAM. Each of the NUMA nodes will only have 32 gigs of RAM local to it. So we want our virtual machines to fit inside that 32 gigs of RAM. I've chosen that number at random. You really can configure up more or less memory in your ESX server for this. So we want our virtual machine to fit inside the 4 cores that this NUMA node has and inside the 32 gigabytes of RAM that this NUMA node has. This avoids having what's called a wide VM, a virtual machine that can't be contained inside one NUMA node. Now normally if I've got a 64 gigabyte ESX server, I'm comfortable running a 40 gigabyte VM on it. It's 40 gigabytes of RAM on a 64 gigabyte host. I've got plenty of room for headroom. But if I know that I have this NUMA architecture underneath and that I know that no more than 32 gigs of RAM is close to any CPU socket, I might choose to create my virtual machine smaller. I might choose to create that virtual machine with 28 gigs of RAM in order that I have uniform access to the memory. I get much more consistent performance if all of the memory is inside the same NUMA node as all of the CPUs. And similarly, I want to keep my virtual machine CPU cores inside that one NUMA node, so I want to create a virtual machine with no more than 4 virtual CPUs in order that they can be concurrently scheduled within that one NUMA node. So we definitely like our VMs to sit inside one NUMA node, but of course to get Marvin the Monster VM, our 32 vCPU, 1 terabyte of RAM VM, here's inherently going to be a wide VM. You won't get a NUMA node with that many cores and that much RAM. So it is absolutely supported to have a virtual machine that is spanned across multiple NUMA nodes, and that would be a wide VM. That will very much be the exception. As I'm sure you're aware, we like having fewer virtual CPUs in our VMs. We like virtual machines with a single CPU. We love them the best. Multiple CPUs absolutely supported and far less painful than they were 5 years ago when I started teaching VMware courses. And they're less painful because we have these multi-core sockets. We have now, typically we wouldn't have this dual socket 4-core, we would have a dual socket 8-core. Or 10-core CPU. So we have a vast amount of CPU cores in our ESX server, and this plays well to multiprocessor VMs if we need them. So we're typically very comfortable with running 2 CPU virtual machines as well. When we get beyond 2 vCPUs, we have to start to think about fitting our virtual machines onto our NUMA nodes. I've made a note about tessellating your vCPUs. So tessellating is where you take a shape and you join multiple copies of that same shape together to make into a nice contiguous sheet of something. What I'm talking about here is that if I've got a 6-core NUMA node, so I've got one of the, maybe a Westmere CPU on my ESX server that's got 6 cores per socket, I can't concurrently run 2 virtual machines, each of which have 4 vCPUs on there. If I have 2 4 vCPU VMs that want lots of CPU time, I can't concurrently run them. One of the virtual machines will get all of its CPU cores running in one time slice, the other will get a maximum of 2, and it's going to be very hard for the VM kernel to keep fair access and avoid too much skew between these virtual machines. If I've got that 6-core NUMA node, 6-core socket, I'm actually going to get better performance out of my virtual machines if those 2 virtual machines each have 3 vCPUs. Because 3 vCPUs side by side fills one 6-core socket. They can be concurrently run. Now, this doesn't just apply if I've got 2. If I had 20 virtual machines each, which was 4 vCPUs, sitting on this 6-core per socket Westmere server, there's going to be a real juggle of the virtual machines to schedule them because the number of vCPUs on those quad-core VMs doesn't fit evenly into the 6-core sockets. Whereas it's much easier for the VM kernel to schedule the VMs if they are 3 cores per VM and they fit inside as a pair side by side inside the socket. And of course with the numbers that I've given for 6-core there, if you have a 1 vCPU VM, a 2 vCPU VM and a 3 vCPU VM, all 3 of those can concurrently run on one 6-core socket, or we could have 3 2-core VMs, or 2 2-core VMs and 2 1-core. So this sort of mixed together, but thinking about how they'll fit together into the number of cores per socket is a really useful structure, and it can end up giving you faster performance in your VMs by taking CPU cores away from them. Often people are uncomfortable with the idea of having an odd number of CPUs in your VM, but it's absolutely possible. It works perfectly. There is no inherent requirement that the number of CPUs in your VM be a power of 2. And once you let go of that idea, and I certainly had it, the idea of having 1, 2, 4, 8 was the right number of CPUs in my VM. Once you let go of it and you say I can have any number between 1 and 32, then you start thinking about other ways of fitting it in. So fitting your VMs inside an neatly inside a single NUMA node is a really cool thing. Little side note about a really funny NUMA environment. This will be the AMD Magni-Cores. I don't know if they're still shipping, but this was the original 12-core per socket CPU. When you looked at this, it was like Intel's old Pentium D. It was two 6-cores inside a single package. Each of those two 6-core CPUs had its own memory management module. So that socket that was the Magni-Core's 12-core CPU was actually two NUMA nodes per socket. And that led to all sorts of confusion because you might have thought on the surface that you had a 12-core NUMA node and so running 4-proc VMs was a good idea. But in fact your NUMA node was 6-core and so running those 4-proc virtual machines was not a good idea. You definitely need to look under the covers when you're scaling beyond 2 vCPUs per VM. You see that 1 and 2 vCPUs fits well into any kind of multiprocessor environment, any kind of NUMA node size. But definitely also want to think about the memory size to stay inside your NUMA node. Next thing I wanted to look at was a discussion around what sort of clustering you should be doing, where FT fits versus running in-guest clustering, and maybe even VMware HA's virtual machine and application monitoring, and sort of place these things as different tools that you use. As we know, there'll be different tools will be appropriate for different use cases. The fact that you choose not to use a tool for one particular project doesn't mean it's a bad tool. So first off, VMware FT fault tolerance, lovely product. I always call it the most cool product you'll never use because, of course, we know it's limited to a single vCPU at the moment. But it works with any CPU, with any operating system, any virtual machine, and with no application awareness of this. So any application in any VM can be protected with FT, provided it can fit inside that one vCPU limit. There's a few other limits around the hardware. FT is going to double the CPU and RAM load of this virtual machine because we keep that secondary copy that's lockstepped with the primary copy, so that if the ESX server where the primary is running fails, the secondary can take over straight away. And in order to sustain that lockstep, we've got to have VM kernel ports. We've got to have one with a gigabit NIC underneath it for vMotion that's used to create that secondary virtual machine, and then we've got to have a second one which is used for shipping the data between the primary and the secondary virtual machine. So really significant investment in additional hardware specifically for FT. That VM kernel port for FT logging will be an additional thing. Another note, of course, is that the RAM on your FT protected virtual machine, 100% of it is reserved. So that virtual machine will get a reservation equal to its configured memory size. If you're still using slot-based admission control, that's the number of host failures the cluster tolerates for VMware HA, that's going to affect your slot size. It's going to be pretty nasty on your slot size probably. FT, I've got a note next to the single vCPU. That's for now only. You'll remember from earlier that that Stephen Herod has said at one of the VMUGs that the engineering team have cracked multiprocessor FT, and consequently we expect to see it in a coming product release. I don't expect to see it in a point release. I think it's something that VMware are going to want customers to be paying for to get, but that's my cynical view. I have no inside information. So VMware FT is one of the choices around providing availability. Guest OS clustering is another one. So there's been some discussion, actually I think it was on the vExpert internal mailing list, so most of you won't unfortunately been able to see this one. It's a discussion about SQL clustering that doesn't use Microsoft cluster services. So it's an application-aware clustering. It's the equivalent of doing the DAGs with Exchange. It's not clustering, but it is clustering. It's not Microsoft cluster services, well, as it's now called failover clustering. It's an application-level clustering, not an OS-level service clustering. And this is a really cool thing to see because I see this as being cloudifying some applications that previously weren't cloudy. It's allowing you to have an environment where the individual unit of compute, your individual VM, your individual SQL or Exchange server is allowed to fail, but the service itself persists through. So I think these are really cool things to see. And hopefully it will significantly reduce the requirement to deploy out Microsoft cluster services in virtual machines, because cluster services is a pain to work with. There are, my fairly limited experience, you have to have some very specialist people in order to do a good Microsoft cluster environment. your general purpose Microsoft engineer off the street is unlikely to be able to help you produce a good cluster environment. So definitely there's some costs, and of course on vSphere we have some serious limitations around the shared storage for the virtual machines. The shared LUNs have to be raw device mapping sitting on some fiber channel storage that is certified for virtual machines doing cluster services. So there's a whole heap of stuff that has to be done for that as well. The other thing that I was thinking about that plays into the same space is the functionality in VMware HA that does the virtual machine and application monitoring. So it doesn't, virtual machine monitoring is watching the VMware tools and responding to the loss of VMware tools heartbeats, which typically means a crash of the virtual machine, as well as the loss of I/O access and resets the virtual machine. That provides a level of availability for an application, hopefully for one of the more cloud-like applications that is not so stateful, where losing this virtual machine for a reboot is not so intrusive. But the application monitoring is fairly cool, the ability to rewrite your application specifically to work with application monitoring, and there's the hardest part. You've got to set your application up to make a series of API calls to tell VMware tools it's going to start heartbeating and actually do those heartbeats. But it is a way to make your application more available on a vSphere environment than it would be on physical, because you've got the VMware tools sitting there as a watchdog, and then beyond that you've got the VM kernel and the HA agent, the FDM agent sitting there being a watchdog to VMware tools. So it is an availability story, which is really what these clustering things are about. Different ones will suit different use cases, and it's important to understand that we will support all of them. So if it turns up in your VCAP5 DCD exam, you need to understand what the use cases are for each and what the requirements are for each. The good news, of course, is that it's the DCA exam where somebody's going to ask you to build some of these things, not the DCD. Next thing I think we hadn't covered was operational readiness. Now, being as how the people who are putting this together are all the tech people, we've tended to focus on the technology rather than the operation and process stuff. It's the thing that I, as a tech person, feel the least comfortable with doing for customers, is looking at their processes, looking at their people and skills, and working out whether virtualization is going to get into problems because of people and process business issues. And it's not something I normally do, so I've taken some guesses at what I think are the important issues in here. It is something that we need to think about for the DCD certification. Readiness within the customer, mapping of dependencies within the customer. These are things that are relevant to the design activity. This is operational readiness is something that VMware Professional Services identified as a primary cause of VM stall, where we get to 20, 40, 60% virtualized in the customer and then everything stops because suddenly we've gotten to the point where people and process issues are getting in the way, and the technical issues are not a problem, it's the people and process. So you've got to then start to think about how the IT business has to be different, has to operate different as a business unit, because we have virtualization. And typical things are, we've got an IT organization that couples hardware purchase to operating system deployment. So if we're going to build a new server, that's the time when we're allowed to buy hardware, but we don't have a process that allows us to buy a new ESX server just because the load on the current ESX service has grown. Sometimes we don't even have a process that allows us to register in our asset system that we have a virtual machine, yet our asset system has all of the information about all of our other operating system installed. So those kinds of things start to play in. Long-term capacity management is a really important one, something that can end up with vSphere or with virtualization being seen as a poorly performing technology, and we'll see it time and again. So the customer deploys an environment which was designed for a certain workload, and then there's a perception within the business, within IT customer, or within the business of the customer, that new virtual machines have no incremental cost. We have this big infrastructure that can hold lots of virtual machines. So putting one more virtual machine doesn't cost anything. So we'll put one on today, we'll put one on tomorrow, we'll put 3 on next week, we'll put 20 on the following month. And in a relatively short period of time, 6 months, a year, we find that the virtualization platform is grinding to a halt because it's now carrying way more virtual machines than it was ever planned to carry, and capacity management kicks in. We end up having the virtual machine that costs $50,000 because we've got to buy another 3 ESX servers to accommodate the load that we currently have. when already we've had 100 virtual machines which had $0 cost on them. So purchasing new disk, new servers, also just noticing that something's gone wrong, seeing a red alert in the vSphere client. If nobody ever looks at it, are we going to actually know that something's gone wrong? So there's a whole area around people and process. But we as the tech guys usually try and send that off to somebody who's a BA, kind of business analysis person, somebody who does that business component. If you're that guy, great. Having the coverage of both that business analysis and the technical stuff is really valuable. But this operational readiness is something that we as the tech guys often ignore, and the tech people at our customers may well ignore, because we tend to talk to the infrastructure guys, the plumbing guys. Next item on my agenda was data center design. This started as power design, but I couldn't really think of enough things for a full slide, so I extended out beyond that. This is another thing which is not directly how does the virtualization platform go in, but it's what's the impact on the other parts of the infrastructure when I put in virtualization. And particularly if I'm doing a physical to virtual conversion, what are the impacts on the existing infrastructure? What things am I going to consume from it for the duration of the conversion? So if we're trying to avoid this customer by building a new data center by virtualizing a large number of legacy servers into a smaller number of virtualization hosts, do we actually have enough space in the data center to deploy those hosts out now? Wouldn't be the first time that we found, no, we don't, that we're first going to put these racks in the rooms where the IT staff are, run the virtualization platform at great risk in non-data center locations because we can't put it into the data center, there's no space in there. Got to think about that space, we've got to think about power. Typically we're deploying a SAN when we're deploying a new vSphere environment, as well as a large number of high capacity hosts. This is going to be a big draw. Do we have enough unladen phases? Do we have enough balance in the phases to run this up? Do we have enough capacity in the UPS? Do I have enough capacity when the UPS has run out of battery and we've had to switch over to generator? If not, will the business sign off on accepting the risk that if we have a significant power outage during the migration phase, we may not be able to keep everything up? Sometimes you've got to make that call and say we're going to take that risk. Sometimes you say that risk is unacceptable. It depends on the customer. Another one Ben's called up is fiber channel, ports on your fiber channel. So I've only called out network ports, which is implying Ethernet. But fiber channel port licensing, it can be very nasty. If you've got a 32 port switch, but only 16 ports are licensed, when I bring in 8 more ESX servers, I need 8 more ports licensed. I'd love to give you some links to data center design, but I don't have any. This was things off the top of my head. I'm sure if you Google around there will be some links, Adrian. I'm sorry I can't give you any tonight. Transition time, my last point in there is about the shell game to consolidate racks. If we are doing this exercise to retire out a large amount of hardware, and I've certainly come across customers who have retired out hundreds of full-height rack mount servers and therefore have had a vast amount of empty space in their data center afterwards. Do I have enough capacity in my vSphere platform to start consolidating the hardware down into a logical location? So maybe at deploy time, I may have found half a rack here and half a rack there and put a blade enclosure here and a SAN there and another blade enclosure in another rack. When I've retired out all of the hardware in the way, do I have enough capacity to reconsolidate these things down, or are they forever going to be stuck wherever I placed them when I did that initial deploy? It can be an issue. It's particularly the data center manager tends to care about the IT management, or the business management particularly isn't so worried unless there's a big glass wall that's facing this gear. Next item is heading into resourcing. So we hit this a little bit last week talking about resource management with Nick. And I felt it was an area where we could go a lot further and where frequently people have some misconceptions or have some lack of clarity. So the first thing, I'm going to go through shares, reservations, limits. And I wanted to start with limits because they're one of the things that I've most often seen people blog posting about, oh, I've suddenly realized how they work. You'll see a little repetition. Limits on CPU and memory, and since you can do them on network and disk now, always apply. Limits apply even if there is excess resource available. If a virtual machine is limited, it will never receive more than its limit of resource. This is the whole point about the limit. It is always applied even if there is ample extra resource. Consequently, limits always reduce performance, or potential performance. Note about a RAM limit on a VM, really bad idea. If you're trying to control the RAM footprint for a virtual machine, do it by configuring the virtual machine with the right amount of memory. Don't do it with a limit. RAM limits are always very bad for performance in virtual machines, and you get better performance in the virtual machine if it has no limit but has a lower configured memory. CPU limits are also seldom needed. The actual virtual machine almost never needs to have its CPU limited. The only use I can think of for doing CPU limits is if you've got some old DOS games that just run too fast at 3 GHz, you may want to limit the VM down. Otherwise, I can't see any reason why you would want to make a virtual machine run slower than it otherwise would, and that's what a CPU limit will do. It will starve a virtual machine of CPU time. So Adrian's talking about a limit being used to have a specific amount of CPU and memory, and particularly carved off, and that's what I'm talking about with the customer says I should have 4 CPUs and 4 gigs of RAM, but they're not prepared to pay for it. I see limits on resource pools as being a valid thing to do. Limits on a resource pools means that the group of VMs together can never consume more than a certain amount of resource, even if we have excess. And that's typically where I would go with that customer who wants a lot of resource. One of the places I would use a resource pool limit is where I have a customer who has a project. The project is paid for an ESX server, and they say, we want our VMs to run on the ESX server we paid for. You can't mix it up with those other servers. The answer is that you give them a resource pool that has the resources of the ESX server they paid for, but on top of the cluster into which you have put their ESX server. So I, in that case, would definitely have a limit that the resource pool is limited to the resources that this customer has paid for. And that's typically where limits get applied to resource pools. It's where a customer has paid for it. So quite often the limit is applied to pools to keep constraints around. Adrian's pointing out around licensing. Now, the licensing issue is that a resource pool can only be built on top of a standalone ESX server or on top of a DRS cluster. You can't build a resource pool on top of an HA cluster. So that's how Adrian ends up with the comment that you need Enterprise Plus licensing for a resource pool. Not specifically for the resource pool, but if you want a resource pool inside a cluster, it has to be a DRS cluster, which absolutely does require Enterprise Plus licensing. The final note on resource limits. Limits apply all of the time, whether you've got, say, ample resource, more spare resource that's not needed or not. Limits always apply. I think I've said that 5 times now. I think I said it about 5 times when I taught this module today to a class here in Auckland. Next resource control that we get is that reservation one. The reservation's that guarantee. If the VM asks for this resource, this VM is guaranteed to get this amount. And of course, each megabyte or megahertz of resource can only be guaranteed to one virtual machine, one resource pool. So you can't reserve more resource than you have. Consequently, an action that would cause resource to be reserved will fail if there isn't sufficient unreserved resource. VMs reserved because they power on, resource pools reserved because they exist. So reservations are used to guarantee, to protect performance. Resource pools are often used as the place for these reservations, and there certainly has been a historic thing around VMware HA, and with the old-fashioned host clusters, host failures the cluster tolerates, that HA admission control policy meant putting reservations on virtual machines was painful because it made your slot size very large. You couldn't run very many VMs on the cluster if one of your VMs had a large reservation. As you know, we've moved now to using percentage of cluster resources, so that argument is less compelling. There is less reason to avoid putting reservations on virtual machines if you're using percentage of cluster resources. So you can then use those reservations on VMs to guarantee the performance of the virtual machine. And even the people who are very keen on not having reservations on virtual machines, and the prime evangelist for that is Duncan Epping, likes not having reservations on VMs because it makes HA much more certain to start your VMs up. Still concedes that there are uses where important VMs, high priority tier 1 VMs, should have reservations. There's less argument against having reservations now than there was previously. However, you will still get more certain restart of virtual machines if the virtual machines themselves have no reservations. This is why the resource pool reservations are so useful. If you put a reservation on a resource pool, that amount of resources guaranteed to whatever runs inside the resource pool, even if that object has no reservations. If I've got a VM in a resource pool, if the resource pool's got a gigabyte reservation, that virtual machine, if it's the only one in the pool, is guaranteed a gigabyte of RAM, even though it has no reservation of its own. It's a very cool construct. I spent some time testing it a couple of years ago and thought, yeah, this is a good idea, putting reservations on resource pools. Note down the bottom, I saw a blog post from somebody or a tweet from somebody who was surprised that they had misunderstood how HA worked, and I was surprised he had misunderstood. It was under the misapprehension, the misunderstanding, that HA admission control was about protecting the actual consumption of resource by the VMs, and it's not. HA admission control, the HA cluster, protects the reservation, that protects the ability to power on the virtual machine, and therefore protects the ability to satisfy its reservation under failure. So HA admission control will make sure you have enough unreserved resource to power on the virtual machines on the server that failed. It's not going to guarantee that you get the same performance. If you only reserve 10% of the resources of your virtual machine and it needs 60% of the resources in order to provide acceptable performance, then under failure it may not get that 60%. Okay. We do definitely suggest setting reservations to protect the workload inside the virtual machine. Whether you set a reservation on a resource pool or directly on the VM, protect the workload. Final resource pool item was shares. Resource allocation item was shares. So shares is the thing that comes into play if there's a shortage. Limits always apply. Reservations are a guarantee, but there's usually a shortfall between the reservation, the guaranteed resource, and the maximum that can be delivered, which will either be the limit or the configured maximum. Shares is used to arbitrate access if there is a shortage. So here has got a question about HA admission control and percentage of cluster resources, and specifically, if I say 25% of the cluster's resources should be set aside for HA, does that mean 25% of the resources of the cluster cannot be consumed by VMs? Happily, the answer is no, that's not what it means. When I set an admission control policy of 25% of the resources are set aside for HA, that means 25% of the resources cannot be reserved in normal operation. They can still be consumed. 100% of the resources of the cluster, when we're using percentage of resources, 100% of the resources of the cluster is available to run VMs. But we can't guarantee that 25% to a virtual machine, because we have to be able to deliver on our guarantees with our ESX servers failed in the cluster. So if I've got 8 ESX servers in the cluster and I'm designing for 2 failing, that's 25% of the total resources. Under that 2-host failure, I have to satisfy the reservations, and that's what that 25% is about. In normal operation, the VMs get access to all of the resources in the cluster with that percentage. There is an HA admission control policy where that's not the case. If we use the standby host-based admission control in the cluster, where we say this ESX server is not normally going to be used and is only available under an HA failure event, and then we're setting that resource aside, it's not normally available. That scenario is actually quite cool because it guarantees that under your configured level of failure, you will get the same performance as you got before the failure. It's the only HA admission control rules that works that way, that gives you the same performance under failure as you had before failure, because you compromised performance normally. Okay, with the other admission control policies, we would have allowed greater performance. Adrian's talking about a comment from a NetApp representative, and the advice was don't get to the situation where you need shares. I would absolutely agree. Shares only come into play if you're short of resources, if somebody is not getting the resources they want. If shares comes into play, somebody's performance is going to suffer. So the best situation to be in is not to have a shortage of resource. However, we don't all have an infinite budget or a fast enough moving environment that can cope with the changes. So it's not unusual to get a shortage of supply. It's not terribly common. It is typically a symptom of an environment where investment is slow or management is slow. But it is absolutely a supportive thing, and we have the use of shares allows us to arbitrate what happens when things suffer. In particular, it lets us choose which virtual machines perform poorly and protect the workloads of the important virtual machines. But as Adrian says, far nicer situation, don't need shares. Yeah, definitely. Shares are a last-minute solution. They are a gracefully having things go wrong. They're not a having things go right. If shares equation is being applied, something is suffering, something is not going right. And then we start looking back at that operational readiness. If we had good capacity planning, we wouldn't get to a situation where there was a shortage of resource. This is true for in-house. It's less true when we start being the provider of a cloud environment, because customers come to us with a cloud environment and they say, here's some money, give us the resources that I'm paying for. No, I don't want to pay for more resources. Right, so the customer is making choices about the amount of resource, and often in those scenarios, the customer is not very disciplined and starts overloading. So I think in a cloud environment, you're more likely to see shares kicking in because the customers will choose to buy a lower level of service because it's a much clearer visibility on it. Another element about shares is you need to be very clear that the value of the shares is not an absolute. Right? 1,000 CPU shares is meaningless by itself. 1,000 CPU shares needs to be mapped to something you're competing with. Your shares value is only important relative to the things you're competing with. 1,000 shares is great if you're competing with things that have 10 shares. You will win 100 times as much as they will win. 1,000 shares is rubbish if you're competing with something with 10,000 shares, because the 10,000 shares will win 10 times as much as your 1,000 shares. So even though your shares value stays the same, there could be some real issues around differences in resource because other things that you're competing with may have their shares value changed, or the population of things that you compete with may change. You need to very clearly understand it's relative to the things under the same parent that you're competing with where that shares value is important. And I'm going to talk a bit about how resource pools play into that. Now, we know that a resource pool is something that you can create on top of a DRS cluster, on top of a standalone ESX server, and that allows us to carve off a chunk of resource from this larger pool of resource that is the DRS cluster or ESX server. That for CPU and memory, our resource pool can have shares, reservations, and limits, and it just carves off some policies around resources. We've already seen that if I've got a reservation on a resource pool, that resource is guaranteed to the child objects beneath it. But one of the common mistakes, and it's not so much a design mistake as an operational mistake, is to treat resource pools as a static thing. We set them up and we walk away. You can't do that unless you place your virtual machines in them and never make changes to the virtual machines. If the population of your resource pools changes, you can get some real significant differences in performance. And this is something that Duncan Epping has blogged about, and in fact it was Craig Rissinger who wrote the main blog post about this, which is called the Resource Pools Priority Pie Paradox. And it discusses a situation where a customer has built this large cluster and has put two resource pools on top of it. One of which has a relatively high shares. In the little diagram, if you can see it, the left-hand resource pool called RP1 has 2,000 shares. And this is our important virtual machines resource pool. The right-hand resource pool, RP2, has only 1,000 shares. This is our low priority resource pool. And then we've had some virtual machines dropped into these resource pools, and as you'd expect, more people want their virtual machines in the high priority important VMs resource pool. And so the population of that resource pool has gotten large, whereas the population of the low priority resource pool has stayed fairly small. Those two resource pools compete with each other based on the shares value of those two resource pools. The maximum resources delivered to the resource pool will be computed out. So for, what do we got? Between the two resource pools, we've got 3,000 shares. So if that cluster can deliver 3 gigahertz, then to the resource pools, each of those resource pools is going to get 1 gigahertz per share. If we saturate that CPU resource, as Adrian says, this only occurs under saturation. You should avoid that in the first place. But to understand the resource pool, let's say we've got 3 gigahertz to give to these two resource pools. Resource pool 1 on the left will get 2 gigahertz. Resource pool 2 on the right will get 1 gigahertz. And this is straight 2/3, 1/3. But the populations of these two resource pools aren't even. So for that 1,000 megahertz of CPU time being delivered to that right-hand resource pool, we've only got 3 VMs competing for it. On average, they'll get 333 megahertz worth of CPU time. They're in the low priority resource pool, getting 1/3 of a gigahertz per VM. On the right-hand side, we have the high priority resource pool. It's full of all the cool VMs, the important VMs. There's 6 of them. There are 6 important VMs sharing 2 gigahertz worth of resources. They each get 333 megahertz as well. The virtual machines in the low priority pool with a low population have got the same amount of resources as the virtual machines in the high priority resource pool with a large population. Is that what we planned for when we set these resource pools up? I thought we wanted twice as much resource delivered to that high priority pool. If we really wanted that, if we wanted the VMs in the high priority resource pool to get twice as much resource, then the shares value on that resource pool would have to have increased as we increased the population. So what we might have had to do is say, well, in the low priority resource pool, for every virtual machine that goes in, we'll put 500 shares in. And so that low priority resource pool would now have 1,500 shares. And in the high priority resource pool, for every virtual machine that goes in, we're going to put 100 shares on, twice as many shares per VM. So now, sorry, it was 1,000 per VM if it was twice as many. Now I've got 8,000 shares on the left. I've got 1,500 shares on the right. Now I'm going to deliver a much larger amount of resource per VM to the high priority VMs than I did to the low priority. I can only do that if the number of VMs in the resource pool reflects up into the number of shares. I can't do it if I statically set the shares value. If I left them at 2,000, 1,000, and I don't control the populations, then I'm left with this paradox where the same resources are delivered to the high priority VM and the low priority VM. And Craig's done a very gentle diagram. When I diagram this in class, I actually ask students, take 100 VMs, tell me how many of them are high priority and how many are low priority. And usually the answer is it's 95 high priority and 5 low priority, or it's 100 high priority and no low priority. And so we get a much bigger imbalance. And we end up that I can usually make the math work so that the low priority VMs are getting 5 times as much resource as the high priority VMs, simply because we haven't controlled the populations well. You can leave the shares value static so long as the number of virtual machines in both pools is the same. If we had, we've got 9 VMs, if we had 4 VMs in one and 5 in the other, we'd actually get what we were expecting if the populations were equal. It's because we have an imbalance in populations that the amount of resource per VM has ended up being not what we planned on. All right, well, that's the end of the material I've actually prepared. A couple of notes on the end. The VCAP5 DCD exam has still not yet been released. I'm a little disappointed. I was hoping it would be released before we wound up the series, and I'd be able to then wish you all good luck with the exams that you're all about to book. Do keep an eye on the certification portal at vmware.com. The URL there, these slides, of course, will go up, and you'll be able to access it directly from that, but I'm sure you can find the certification site at vmware.com. If you haven't already done so, do book in for a vSphere-5 design workshop. I can see at least one person in here that I can see is booked on one of the training courses that I'm currently scheduled to teach, so it will be ahead. Any sessions that you missed, there'll be a link on this page to my APAC schedule for this podcast, and we've also, of course, got the main podcast page at vBrownBag. And yes, Andy, that is you. If you want to catch up with people who are in your region who are doing virtualization, I would strongly recommend you get hold of your local vMug. This page links to myvmug.org. If there isn't one around, then you could always start one up, provided you're an end-user customer. If you're not an end-user customer, then another way of socializing with people who do virtualization is to start up a vBeers group. vBeers group is simply an informal arrangement to come together and in a watering hole somewhere and talk about virtualization. The beer itself is entirely optional. Soft drinks are perfectly welcome, but the coming together and talking about virtualization is a good thing. I ran a vBeers last night, had a great time just talking with people who are doing virtualization. When we do eventually get the DCD exam out, and you'll recall we had John Hall on a while ago talking about that exam and saying, yes, it's coming, and we're still waiting for it. Murphy's Law probably will kick into play and it'll be announced tomorrow. Hopefully it'll come out very soon. The DCA exam, here I was making a comment about that. The DCA exam, of course, is completely separate from the DCD exam. It's completely different in the way it's run. The beta of the DCA exam is currently running now. So given that the DCD exam had been scored, I was expecting it to be released now. Maybe there's some special event it'll be released at. Come to think of it, there is a VMware event live online next week. Might be worth watching for. Do tweet. If you head towards the certification, if you do your certifications, I keep a search up of vBrownBag, and lots of people do tweet stuff around vBrownBag, so do so. And then we will be following up this session. There will be a separate registration for the call series on GoToMeeting for the DCA, the VCAP5 DCA. And then also the other thing is my project that I don't know if I've mentioned on this podcast. I put together a little project to help you automate the build of your vSphere-5 lab for training. Not relevant for DCD, but great for DCA. Head up labguides.com and there's an AutoLab link on there. The aim is to give you a package of shell virtual machines with some automation in them. You bring your installers for vCenter, for ESX, and for Windows, and use these shell virtual machines to very quickly build up a lab. And I've done a huge amount of automation in it so you don't have to mess around with installing Windows and installing SQL and installing a domain. All of these things are done automatically for you. And in fact, while we've been on this podcast, I've had a domain controller that's been building itself the whole time. Really proud of this material. It's produced a really nice little lab, and it runs on a single PC with 8 GB of RAM under VMware Workstation. So it's a really accessible thing for you, really easy to rebuild. Labguides.com, you might guess from the name that myself and Nick, who puts these things together into the feeds, he and I are writing a lab guide to help people who are studying for VCP certification, and we hope to have that ahead of VMworld. If you're heading to VMworld, I'm planning to be there, as is Nick, with a bit of luck. He needs. We're both looking for some sponsorship to get there, and also got some sessions around lab guides and the Auto Lab, which is that automated lab build environment. Do watch out for the tweets. I'll be asking you if our session gets through the first cut to help support me and get us on there. So this has been the series. It has been a lot of fun. I've really enjoyed the questions coming backwards and forwards from people.